will help you read lot of IPR, intellectual property rights, because this is the direction. And anything that is you see in your environment today, you can relook at it and redesign it with a sustainability matrix in mind. At present, when the designing is done, it is designed for point of sale. So is it desirable at the point of sale? This is one of the important criteria in designing. The other criteria is that it should be durable. Okay, so as far as the engineers are concerned, they would like to make it durable. As far as consumerism is concerned, they would like to make it fragile, have a short life so that people can buy more. There is a need to bridge this gap. As a matter of fact, the engineers and designers both have to work on designing products which are attractive and long-lasting and sustainable. They are not in conflict with the environment. With this short introduction, let's move forward. Now, here are some living creatures. And you see that living creatures are designed, they're very fragile. You can fire a gunshot and they'll be killed. But a tortoise can live up to 187 years, an elephant up to 86 years, a tree up to 3,000 years. And again, a coral reef, which is again a living organism. The entire coral reef, consisting of many, many creatures, is also a living organism in itself. And that can last for 3,000 years. Okay? So when you look at this, there is no reason why products need to be replaced after 6 months or 1 year or 5 years. When I was young, a ceiling fan or a sewing machine or a refrigerator would last for 20 years without any fail. Okay? Of course, we used to do some maintenance. Annual maintenance would always be there. Oiling, etc., would always be there. Now, what has happened is that all this oiling and servicing and maintenance has disappeared, and the product becomes useless, and then we throw it away. Now, the result is this type of calamity that you see. So there is tremendous amount of electronic waste that is piling up, and this electronic waste is valuable. Same with cars, okay? And the result of that is birds dying because they are swallowing plastic pieces. So an island in Pacific, which is about 6,000 kilometers away from the nearest land, there the birds are eating plastic. That island is not the source of the plastic. The plastic floats 6,000 kilometers, reaches that island, and the birds, thinking that they are some type of unique novelty living items, and they pick them up, they eat them, and the result is this. And then you also see what is happening to our national animal. So you see so many cows, they are grazing what? Your dump yards, dump. And then you see there's a tremendous climate change effects that are happening, and flooding is happening where it should not. And you see the type of calamity that is ensuing as a course, due course. Further, you see entire coastlines are engulfed in forest fires. Icebergs or mountains of ice, which is essentially a storage of water, okay? They are breaking down, and they are going into the sea, and they will melt in the sea. And the result will be the rise in the sea level. Droughts may happen, will happen. Flooding in cities will happen. Okay? More hurricanes will happen. And they have already started happening. So it's not something new. And this will grow in intensity. And that is why it's important for us to progress in a sustainable manner. Now, how is it that nature is so creative and yet sustainable? Nature has been, life on earth has been there for 3 billion years, 3.5 billion years. And there is so much of variety of life. Okay. There is not a centimeter of space, square centimeter of space on earth, which does not have life on it. You don't have to search for life. It is there. It's there all around us. And there is immense amount of variety that you see. Okay. And yet, in spite of all that variety, we find that nature is so sustainable. Life on earth is sustainable. It is the human being which is creating the unsustainability. So it is important for us to understand that what are the laws of living that nature follows and shares, because of which it is so sustainable. And maybe some of these insights, I personally find it very useful. You can take these insights and bring them into the domain of engineering, and then see how we can redesign things so that they become sustainable. It is the absence of these insights that is keeping us away from being sustainable. So what are these laws of nature that we'll talk about? So the first law is that whatever has to come from whatever is there around us. So this is very interesting. Okay. So if a seed has to sprout and become a tree, it cannot depend on somebody to come and water the tree. Okay. Or to give it nourishment. It has to be self-sufficient. It has to be Atmanirbhar as we talk of today. So Atmanirbharta is something which is integral to life itself. And so what is happening here is that the life has been so designed, the design has been so designed that it has to sustain itself on local materials. So one of the important things that we do today when it comes to LEED certification and making buildings sustainable, do not use material which comes from long distances. So it's in that direction. But in nature, any living creature cannot depend on somebody else to come and feed. The mother may help, but by and large, it has to be self-supporting. Now you see the examples of the coral reef, and you see the example of the anthill. And this anthill is, how tall is it? Maybe 11 meters, 11 feet high, 2 meters. Okay. And it is built by what? Little termites. Okay, termites. And the size of the termite is how much? Maybe 2 centimeters, 2 millimeters. So this 2 millimeter creature working together is creating an edifice which is 2 meters high. Or why 2 meters? So this would be about 4 meters high. So you imagine the type of a skyscraper this termite is able to create. Look in terms of scale, okay, and see how big a creation it can do. And the entire material is coming from where it is building. There are no transportation trucks, or there are freight trains which is bringing the material. Okay, it's all being created locally. And same is true with the coral reef. All the material, the diversity of material that goes into the making of coral reef is happening there itself. It's not coming from anywhere. And it is all happening at room temperature, at the normal temperature that is prevailing. Okay? Unlike this, if you look at engineering, we believe in heat, heat, and beat. So a lot of heating is involved, a lot of beating is involved. Okay? And then we may be chemically treating it. But here it's all happening at a room temperature, at the normal ambient temperature, let's put it that way. Okay, so now, if you look at the design, so at present, what do we do when it comes to design of a product? We make some engineering drawings, okay? And there would be volumes of engineering drawings that we have to create. Okay? And then somebody will do the tooling drawings. Okay? And then somebody will do the layout of the plant in which those drawings will be prototyped. And here what is happening is that you have a bacteria, how it multiplies itself, it divides and multiplies. Or you could have plants where the baby plants can grow on the edges, or you have ferns in which spores are growing, okay? Or you have seeds, or you have eggs, or you have the womb. Now you see, as the life becomes more complicated, it requires more resources. The seed, for example, has fat and carbohydrate around the DNA and the RNA, which is contained in the seed. So the life is kick-started with the resources which is there already in the seed. Same with the egg. Whatever material is required for the prototyping of the chick is there within the egg. It is a sealed thing. Nothing can come from outside. And yet life can grow inside. And how it grows is that there is a design plan. There's a plan for the form of the product. There is a plan for the manufacturing of the product. And the basic raw material is there to initiate that process. And this is how life comes about. When it becomes more complicated, now mother has to produce the raw material that is required for the baby, and the baby slowly grows within the womb. And the mother has to continuously keep the supply of the material and keep feeding it to the baby. So unlike in the case of the egg is contained, it is isolated from the environment. All material that is required has to be contained within that egg. But in case of the womb, it's a different story. But nevertheless, life is going from resources which are locally available. Mother is providing the resources. It is locally available. So it's a very important thing that when we design any item, we should not depend on material which is coming from long distances. Or let us try to minimize it. Okay, so to begin with, let's minimize. These days, when you look at CAD programs, and they have some built-in utilities, sustainability assessment utilities, then they would also assess where the item is to be manufactured and where the material is coming from. And using that, they develop the carbon footprint. So the carbon footprint essentially means how much of carbon is being used, which is a measure of the energy, okay, is being used in order to make the material, the processes, and ultimately the product. How much carbon footprint is attached to that product. Now, that was our first law. And the first law was that whatever local resources are there, within that you have to work out your plan. Okay. The second law is that the nature species are aware of itself, its boundaries and the forces and the resources that are for and against its integrity. Now, this is a very important concept. And actually, these insights have been taken and put in our scriptures. The entire Vipassana meditation is actually based on this. So, unless life is able to, see, life is something which has to interact with its environment for its sustenance. If it has to interact with its environment for sustenance, then it becomes extremely important that it should be able to assess what is it there in the environment which is conducive to its health and what is not conducive to the health or injurious to the health. So continuously all the time, consciousness in any life, living creature, is monitoring its environment. And it is monitoring the sensations that are happening on its body. And whether those sensations are pleasant or not pleasant. And this is how evolution actually happens. So it's a very important area. There could be a PhD dissertation. Why one PhD? You could have many PhD dissertations exploring this topic. That how is it that any living species is able to interact with its environment and choose what is good for it, what is not good for it, and then devise strategies for its growth. Now you see some of those examples of the same thing. And whether it is a plant or it is a penguin or it is a bee and a flower. So the bee is aware of the flower and is aware of what is there in the flower, what is good for it. And then it is also aware of what the flower needs and how you can develop a symbiotic relationship between the two. Okay. And this is the interesting part, that nature, unlike we ever told by Darwin, that was a very long, I would say, early stages of evolutionary theory. In 1800, he came up with this laws of natural selection. Okay? And he talked of adaptation. And then he also talked of survival of the fittest. Okay? Since then, a lot of work has happened in evolutionary biology. And what we have come to the conclusion that there is tremendous amount of collaboration and sharing and symbiotic relationship that happens. And it is through this collaboration and sharing that life is able to optimize itself in terms of its requirement for energy, data, material, space, and so on and so forth. Now, this is another very interesting thing, that nature species is trying to make the environment more habitable. Now, if it does not make it more habitable for itself, okay, then its progeny will not be able to survive. So they are using biochemical pathways for doing what they want to do and are aware that, yes, I should not produce any bioproduct which harms my environment. So this is another thing that as engineers and designers, we have to take care of, and we have to think all the time. What is it that we are doing? जैसे वो हम लोग कर्मा थ्योरी के बारे में बात करते हैं कि बेकर्म आपके कर्म दूसरे को कैसे अफेक्ट कर रहे हैं और how your karmas are affecting the others decides your future course of evolution. So this is very important, very, very important. It is just a matter of becoming aware. Once you become aware, then it is possible to redesign your products in a manner, okay, that your environment becomes more happy. And it is happening these days. Like, for example, if Maruti is there, Maruti is manufacturing cars, then it will develop its environment in such a fashion that its business becomes more amenable. So you will have maybe vendors around you. Yes. So these vendors are producing material which is required for the making of the car. Maruti factory is very near my house in Gurgaon. And there is a lot of traffic jam that happens in the evening. And at the evening time, what also happens is that these are the big lorries which carry the cars to different places. So there can be a traffic jam. So what Maruti does is it deploys its own people to ensure that the traffic is running freely. So in other words, what they are doing is they are making the environment more habitable. If they did not do that, they would have to rush away from their present spot and maybe build somewhere else. And this is just one example. There are many, many such examples. And that is why you have this CSR program, Corporate Social Responsibility Program. So that whatever factory, wherever you are, that factory uses a certain amount of its profit to make its environment more conducive, more acceptable to itself. Here is an example of a beaver's dam. So these beavers, the beaver is something like a nevla, something like that. So it's called, I don't know what it's called in Hindi, but beaver. Now they build dams across rivers. And by building dams, they contain the water and it is possible for them to breed better. And it also produces a new ecological system which helps other living creatures also, and it helps them also. Then nature design exists in symbiosis with the environment and other species. And this is another thing that we all have. So nature is, I would say, is so socially conscious. And that is why it is able to survive so long. Unfortunately, when I look at our day-to-day social news media and TV news media, we are fighting with each other all the time. I don't see this type of fighting ever happening in nature. Yes, a lion or a tiger may chase a cow, but once it has eaten the cow, आराम से बैठता है, relax करता है, let the cow graze, no problem. So nature designs exist in symbiosis. They help each other, they support each other, they care for each other. There is coexistence, there is collaboration, there is sharing. And it is enriching the environment. If today we have so much of oxygen in our atmosphere, this oxygen has come from living creatures. So living creatures have produced that oxygen, which has supported future life. Okay. So this is something we should again understand. And here are examples of it. Of cyanobacteria uses sunlight to create energy in material. There was a time when they wondered that when a tree grows, how much of the tree comes from the earth. And so they did some experiments. So they did the experiments, they grew the tree in a pot, okay? And they weighed the pot before and after and between and so on and so forth. And they were able to estimate the weight of the tree and how much material loss has happened within the pot which contained the earth and the clay. And they found that very little contribution is there of the earth. Earth is holding the root and is providing some chemicals which are necessary to act as a catalyst, as a moderator in the synthesis, biochemical synthesis. But most of the work is happening through the sunshine. So this cyanobacteria actually evolved into lichens, and then lichens evolved into trees. But the basic process of producing oxygen to support and enrich life has continued. Then there is something very interesting that was recently discovered in some researchers, that the trees in a jungle, trees are rooted. They are like sadhus and saints who don't go anywhere. They just sit at one place. Okay? And whatever comes to them, they live on it. So sunshine comes to them, the rain falls, they get the water, and they keep growing. Now, if you look at Darwin's theory, then there would be what? Competition among them, and there would be no collaboration. There would be survival of the fittest. One tree will compete with the other, will try to kill the other. But no, it's not so. They found that there is a network of roots and fungi that goes around the roots. And it is this fungi which is carrier of information, also carrier of nutrients. And a tree may support another tree of a different species also. A big tree may support a small tree, which is growing under it, which is perhaps not getting enough oxygen, enough sunlight. So it is providing them the nourishment. Like a mother provides nourishment to her baby through the milk. Okay? So this type of a thing is happening. And I think this is something which we have to understand, that the collaboration, cooperation, caring for each other is very important. It is there. It is just there. Everywhere I see in nature, it is there. It is least in human beings. And I think we have to understand that, that how we have to grow out of it. Here again some examples. I'm not sure is this image of the dog may be photoshopped, but it is very cleverly photoshopped. But nevertheless, these days you will see many such images and videos on Twitter and Facebook. People are sharing it, where you are amazed at the amount of love and care that animals have for each other. It comes as a surprise to us. We are fascinated. I find such videos becoming viral just because it questions our thinking. It tells us, look, the world is different from what we think it is. Here is a very interesting story. I would suggest you go to the YouTube sometime and look up Yellowstone Park. And there was a time when people thought that these wolves are horrendous creatures. They were spoiling or killing the sheep which were there, or farmers around the Yellowstone Park. And they all got together and they said, this wolf need not exist. And they exterminated the wolves. So there was not a wolf for many, many decades. And the entire ecology of the Yellowstone Park started changing for the worse. And then, of course, scientists, they got together and they investigated. They said, no, wolves are playing a very important role. And they reintroduced the wolves in the Yellowstone Park. And the entire ecology once again changed. Water started flowing in the river. It changed the course of the river. So you see how things are interrelated, we do not understand. And we have to understand that and appreciate that. And this appreciation we have to bring in our engineering, in our design. And once we do that, we will become better human beings, richer human beings. Okay. Then there is equifinality, the law of equifinality. And it says that there are plurality of paths to achieve a goal. So every living creature has a plurality of paths to achieve a goal. So the older machines, of course, mechanical machines, older machines would have only one path to achieve a goal. But modern electronics, you see, that they are designed in such a fashion that you have a plurality of paths, more than one path to achieve a goal. If we have to improve reliability, then often what we have done is that you provide some redundancy. Okay? So if something fails, then you have another path through which the process can happen. If my body has to be cooled, okay, so if it is very hot and I'm sweating, the body has to be cooled. There are many ways of cooling it. I can fan myself, I can drink some water, have an ice cream, okay. So many ways. Maybe take off my clothes, okay. Switch on the air conditioner. So many paths are there. Okay? If I have to increase my blood pressure, I want to increase and enhance the flow of blood in my veins, then there are many paths through which I can do it. And this is important to understand. And here are examples of different types of eyes. Enormous number of eyes designs that you have. Some for short distance. So just imagine a caterpillar. Okay, it has to eat something which is at short distance. And then there is the eagle. It has to identify its prey from a long distance. And some have to see underwater. And some have to see under at night. So this is how creativity comes. Okay? So there are many challenges, many ways of doing it. And you take that challenge. You cannot question the resources that are available to you. Whatever resources are available in your environment, you have to make use of that. And you have to choose your biochemical pathways and your method of synthesis, your design and the process of manufacturing, which will utilize the resources that are available. So remember the first law that we talked of, and again it is reflected here. The type of soil you have on which you have to travel will decide the shape of your hoofs. So whether you are walking on grassland, or you are like a mountain goat, or you are a spider, or an ant. Okay, so the design of your legs and your paws and your feet changes. So this is where the creative challenge is, that we are not questioning the resources that are available. We are adapting ourselves to the resources that are available. So again, if we keep this in mind when we are designing products, okay, make an effort. See, creativity is about taking a challenge. So you say, okay, this is what I have, and I have to get the best performance out of it. So none of these creatures have suboptimal performance. They have highly optimized performance. They are able to achieve the task. And similarly, we can also take an engineering and a design challenge and design things for a more sustainable existence. Then homeostasis, again, reaction within specification. Okay, so here what happens is that certain equilibrium is established and you maintain that equilibrium. Okay? So the pH of your blood will be maintained. Okay? Your body temperature will be maintained. And the body will do all types of adjustment to ensure that it is maintained. Very important concept, equifinality, homeostasis. Anybody who's into the area of system thinking knows these concepts. And as designers, we should be aware of it. Modern electronics, modern designs are making use of these concepts. And we designers in India and our education system also has to start thinking in that direction. Then systems are synthesized to sustain their integrity. It's a very interesting concept. So in nature, you do not find anything over-designed. It is also not under-designed. If it is under-designed, it will not live for 185 years. A tortoise will not live that long. An elephant will not live for 86 years. Okay, and yet it has to sustain its integrity. It can't fall apart. Okay? And rarely you have a sprain in your leg. Rarely. Most of the time, you are able to walk around without any problem. Okay. You are able to balance yourself. If there's any hindrance, you are able to protect yourself. A tiger, most of the time it may be just lying or walking slowly. But when it comes to catching a prey, when it has to catch a buffalo, then it runs, and it runs at 120 kilometers per hour. Now, if I design a car which is to run at 120 kilometers per hour, just look at the type of materials I have to use there. But the tiger is able to sustain that speed. Not only able to sustain its speed, it is able to accelerate also. So the moment it reaches a buffalo, it is near the neck, it has to deaccelerate. Then only it is able to catch. So sustaining integrity is important. This is again one thing which we have to keep in mind when we are designing products or we are designing systems. Their integrity under different circumstances, odd circumstances, difficult circumstances, that integrity has to be maintained. It has to continue to work. It must continue to work. This is what is meant by their integrity is maintained. This was more to do with that homeostasis. Now, species are designed for performance and also to moderate interaction with their own kind and with other species. So this dichotomy that we have today between engineering and design is totally irrelevant. In nature, you don't see that diversity. In nature, you have Saraswati also, and you have Vishwakarma also. So Vishwakarma is looking after the technical design and Saraswati is looking after the emotional design. Both have to be there, both have to work together. When you design a product, when you design a system services, please collaborate, work together and design a product which can sustain itself, sustain its integrity, can perform its job, and yet it is also able to gel well with its environment, with other products. And the world is moving in that direction. So when we are talking today of interconnectedness of things, IoT, so how things can be connected together through Bluetooth and Wi-Fi, okay? And then the products can be connected to the factories, to the service people. That's what we are talking of. So no product is now living in a silo. It has to interact with other products also. Okay? And it has to be self-sustaining. It has to maintain its integrity. It has to fulfill its technical function. But at the same time, it has to integrate itself with other things. And this is where our engineering education has to evolve. This is something which is lagging in our educational system. Don't spend information, energy, or material more than is necessary. So while you are living, you are using the minimum amount of energy, material, and information that is necessary. Otherwise, our brains would simply explode. We will not be able to work. And if you look at the theories of vision and perception and how we capture information and what is it that we see? Do we see everything every time fully once again? Or do we just see part of it? We refresh our previous memory. So we'll find that there is tremendous amount of optimization that happens. And we see today. So you have energy rating with products, 5-star AC, 4-star AC. Whatever it is, sooner or later, the world has to move. Engineering and design has to move in the direction of sustainability. We like it or not like it, those who are able to willingly move in that direction will benefit, will prosper, will be in the forefront. And so I would urge you, young teachers, engineering teachers, that you think in this direction. Embrace this learning. And I'm so glad that the institution that Manav Rachna, a very nice name, it's talking of Manav Rachna. So how we have to reconstruct the mankind. And this is the direction in which we have to reconstruct the mankind. This is another important concept. Life's regime must strengthen the capacity to live. Okay, so every living creature has a regime, a life regime, which means what? I will wake up at this hour. I will go to sleep at this hour. I will exercise at this hour. I will do my work at this hour. I will eat food at this hour. Now, these regimes are designed in such a manner that you become more healthy. So not only you are able to live your life, but in the process of living life, you actually become more healthy. Okay? That is why we often talk of lifestyle diseases. We have taken up regimes which are not conducive to our health. And in other words, we have taken up lifestyles which are not conducive to our health, and so we have lifestyle diseases. Tomorrow's products will also be designed keeping this in mind. And we do that. We say, here is a mixer grinder. Please use it only for 30 seconds. After 30 seconds, give it a rest. Now, what they are saying is that that's the regime you have to follow. This is the product, and you have to plug it in 220 volts. Okay, and there should be no spikes. Okay? So there is a filtering system or some system. You must polish your shoes. If you don't polish your shoes, then the life of it will deteriorate. So it's part of the life regime. You must repair your building. Okay, so if there is a leak happening on the roof, please go and repair it. Part of the life regime. Okay, there is something like a daily maintenance, a weekly maintenance, a monthly maintenance. Okay, there is something called an annual maintenance. So we have to think all products are to be thought of in that direction. And if there is a product which is unsustainable, look at these different laws that I'm talking of, and you can tick out, you can tick that this is what is not being followed, because of which it is unsustainable. So some examples of life regimes. Now, life supports life. And this is another thing that has taken us many, many years to understand. Okay? There was a time when we thought that all bacteria and viruses are bad. And then we invented broad spectrum antibiotics, which will kill all bacteria, without realizing that there may be bacteria which is actually helping us. Today, they have found that there's something called gut bacteria, which is important for our well-being. There is bacteria in our mouth, which produces nitric oxide, which helps in the dilation of the blood vessels. It's an important bacteria for our living. We may use a mouthwash which kills that bacteria. If we breathe through our mouth, then what can happen is that we are not breathing through the nasal cavity, which connects our nose to the lungs. And along this nasal cavity, there is a lining on which this bacteria grows and produces nitric oxide. This nitric oxide is not supplied to us. And people's health deteriorate very fast. So there were many people around the world, when they sleep with their mouth open and they breathe through their mouth. So when this discovery took place, then there were thousands of people in USA who used to do that. They became aware by using those Fitbit watches. So that would monitor them during the sleep and the saturation, oxygen saturation, and so on and so forth. And they found that they were actually sleeping with their mouth open and they were breathing through their mouth. And then they were taping their mouth. So they would tape their mouth when they went to bed so that they breathe only through their nose. And their health actually improved. So growth only happens through interdependence. Life is so designed that we are making use of other life around us. And the last one, that whatever we do, we must leave behind a legacy of support. So whatever products we use, whatever the products companies manufacture, okay, they must take care about the end result. In nature, what happens is that when any living creature dies, it actually increases the GDP for new life to come into existence. Because what that living creature has done, it has used the lower level material to make more complex, higher level molecules, which make it easier for life to process them and use them to support life. So this is another important concept, and I think it has a lot of relevance in engineering. We, in a way, do it also. There's no doubt we do it also to some extent. But all these principles, we have to now use them in a more conscious manner. More actively, we have to use them. Okay? So let me move. So these principles in nature values shares among its creation. These principles, nature values. So all these principle is valued. It is given a lot of importance by nature. It is shared by all living creatures. Let us say, I don't want to get into a debate whether it's all. I'll say when I say all, it means 95%. Let's put it this way. Values are actually very important. There is no engineering, there's no design without values. Engineering uses a certain types of values. Design uses other types of values. So we have to become aware of, and once we become aware of values and their importance in our thinking and the importance in shaping our environment, then we can progress better. We can think better. So when I look at all this, I find that there is the zeroth law, and the zeroth law says that creativity and care, these two things are very important. Nature is very creative. Nature is also very caring. And both are necessary for the continued existence of life. Now, what are the insights that we have gained through this journey through nature? First of all, design and manufacturing is integrated. Now, why do I say that? Because if you look at a seed, what does it do? There's a design here also. The form of the tree is also there. And the process of manufacturing the tree is also there. Now, the future of engineering is in this direction. Design and manufacturing will get integrated. And it is already happening. The moment we have switched over to computer-aided design, our design was made digital. Because it became digital, it was easier to manufacture it using CNC machines, using 3D printers. So design and manufacturing is being integrated. It will continue to be integrated. The more you integrate it, the better it will be. So this is the direction of research. Anybody can specialize in this area and say, our objective is to integrate design and manufacturing. Let us identify gaps and let's bridge those gaps. The second is that to design a long and a useful life. So there is a very interesting video which I would like you all to definitely see. It's called Light Bulb Conspiracy. So you will forget it. So I don't mind if you take 30 seconds off and search on your mobile phone. Search on YouTube. Light Bulb Conspiracy. LIGHT, Light Bulb Conspiracy. Very important video. I found it extremely fascinating. It helped me understand the course of life that I was leading and where it was all coming from. And what is the root of consumerism? And consumerism is something which goes against designing of products with long. And it's important for us to relook at designing of products and design them for longer life. Some of you may say that if a product has a very long life, then it will become so boring. Fine, you don't have to throw it away now. It is boring, you give it to somebody else will use it. You don't have to put it in the dustbin. And there are so many people who do not have things. Some people say that, look, if products have short life, then the industry will suffer, and then there won't be customers to buy. No, it is not. Just not. The market is very huge, and the market was very, very huge, and that is why they started talking of globalization. That through globalization, they would have more market reach. And the third is use local resources for prototyping. So what is prototyping? When the egg is there and the chicken is formed, तो वो prototyping हो रही है. Womb में बच्चा बन रहा है, that is prototyping. अभी manufacturing नहीं हो रही है, अभी prototyping हो रही है. Manufacturing कब होती है? जब वो procreate करते हैं. अब manufacturing हो रही है. And then they are multiplying themselves. Okay. But here it is just a prototype. Then the fourth is do not pollute the environment in which we live. So be conscious of the byproducts that you produce and how you can recycle those products, use those products, byproducts. Enrich the environment for living. So improve the quality of the environment. It's very important. Use least space, energy, material information for functioning. So we have to keep tab of that. Understand how much energy I'm using, how much space I'm using. So to reduce space, there are so many products which have been designed, which save on space, generate more space. You have folding chairs, you have collapsible items, you have bunk beds, you have box beds. Okay, so it saves space. Coexist, collaborate, and share. So different disciplines have to coexist, they have to collaborate and share. We have to adopt and we have to adapt ourselves. These are two different words. We have to adopt ourselves and we have to adapt ourselves. So we have to adopt things. So take new insights, new knowledge, new facilities, adopt them, make them. And then adapt means that you adjust yourself, adapt yourself. Then service, maintenance, and upgradation. This is what we see in nature all the time. So a child is born and then it learns from its environment and it grows to be conducive to its environment, to be compatible with its environment. It maintains itself and it continuously upgrades itself. We talk of skilling, reskilling, unskilling, vision, revisioning, and so on and so forth. So you have to upgrade the design, you have to upgrade the environment. So all design has to be done, all engineering has to be done, keeping in mind that upgradation is necessary. And lastly, we leave behind a richer environment for future life. Now, let's come to some engineering. I think we have 2 hours, we have plenty of time. Now, this is your present product life cycle. What you see here is the product life cycle. It begins with a concept, then it goes into the development, then it goes into the prototype, Then you launch that product. Then you manufacture that product. You distribute, use, service, recycle, and it happens like this. There can be minor variation from product to product and so on, methodology to methodology, from company to company, but by and large, this is the process that we use. Now, if you look at nature, the concept and development is merged together in the sperm, in the egg, in the DNA. The DNA and RNA together has all the information that is required for concept and its development. Prototyping is happening, as I said, when a seed sprouts, it's the prototype. Okay? When there is the egg, and in that egg, the prototyping is happening. In the womb, the prototyping is happening. Okay? Then, of course, there is the birth, which is really the launch. Okay? And then there is growth. In nature, there is growth. It is interacting with its environment. It is learning new things. It is adapting itself. It is upgrading itself. And then after it has reached a maturity, then it produces more. So when the hen, the chick becomes a hen, then it starts manufacturing more eggs. Then there is distribution and use. Now, if I compare this with nature, what is happening in nature, I find that there is a lot of grow, use, and service, a lot of interaction with the environment. So it's the product are not closed. Products are upgradable in nature. In man-made environment, they are very closed. You have to design them to be upgradable. That's an important insight from nature. And we find that this is what is lacking. At various stages in nature, we find that this interaction with the environment, this predation consequence is built into our system. It's built into every creature. And this is how evolution happens. Okay? So keep this in mind, okay? And then relook your engineering practices and see how you need to modify your engineering practices so that your designs, your engineering, the man-made world is more sustainable. Now, these are the two approaches that one sees. One was the earlier approach that I was talking of, okay? And the other is that you are interacting with the environment. Okay? So, environment is producing material, it is regenerating material, and then it is feeding back. Okay, so what you see here is that, and then if, let's say, the technological environment is there, then it has to be designed in such a fashion that it is compatible with the nature. So if you make it compatible, then the nature becomes a partner in it. If you cannot make it compatible, okay, then you have to create a closed loop. You create a closed loop and then you cycle within that closed loop. You don't let things go into the nature and pollute the nature of the environment. So keep this in mind. It's important diagrams, but once you have this broad insight in mind, okay, either you must work, evolve your strategies so that they are compatible with nature. And nature can be a partner in processing the material, or you should create closed loop of the man-made world. So you do not affect the nature. So these are the approaches that we have to keep in mind, broad approaches. Now, what I do is my last phase of the talk, and here I'm just taking a small case study, which we did with some students. And here we are looking at how we need not generate plastic waste. So what is happening today is that we go and buy things, and with it we bring a lot of plastic, which is really waste. And this waste litters our environment. So if you take a camera and you go around in your locality, and then you photograph all the waste that is there, you will find that the maximum waste is because of plastics. If you remove the plastic, then 90% of the waste will not be there. So let us understand how we can do it, give a thought to it. Maybe you can give some ideas. So maybe I should stop here for a moment, okay? And let's have some interaction. What is it that you have learned? And then we'll go through this case study. In the meantime, you also think about this plastic waste that is there and what can be done to minimize this plastic. So I will stop sharing, and then we have a little bit of interaction. So let's have some questions and answers, some comments, your thinking about it, all this sustainability talk, climate change, environmental crisis. Is it all hunkam bunkum? Or is it very relevant? Is there something we can do about it? What can we do about it? What are your observations on it? So the house is open.
Dear participants, is there any query?
I'm sorry, this online system is not very good. Yes. We have to have a face-to-face discussion. But anyway.
Yes, sir. Few people participated earlier in the earlier sessions. Now we are waiting for. Dear participant, is there any query?
No, they have to be queried. There is no question of if.
Okay.
Yes.
They have to.
if you have sat here for 1 hour and listened to me, yes, then you have to also speak. You have to get a chance to speak.
Mr. Jaideep Singh from IIT IIT Guwahati. Sir, you have switched on your mic. Is there any query, sir?
Sir.
Yeah.
Sir. Good morning, sir. This is Jaideep. Sir, I have always thought about it. Why we are not using like our own bags to take something out from the market? Actually, if something is delivered in our home, that is always wrapped with the plastic. So if it is a very big thing like a fridge, TV or something, then it's a problem. But for the small things, we can use our own packages to get it delivered in our home.
Yes. Now, how will you supply the package? So I know that when I was young, my father would go shopping once a month. And then when he goes shopping, he would carry with him something like a dozen cloth bags.
Yes, sir.
And there'll be bags inside bags. And then different items would be put into different bags, and then he'll bring them home. So urad ki dal would be in one bag, chawal would be in another bag.
In another bag, yes, sir. Yes, sir. So instead of plastic, again we can like use that old culture. We can use the clothes instead of plastic bags.
Yeah, but people want to be modern also. This is the big problem now. So your
Yeah.
generation would not like to live the way your father and your grandfather lived. But
Even
now,
even I used to go with my grandparents. I used to keep that cloth bags in my hand when we go to the market and we purchase some vegetables from there, and we directly put that vegetable in our bag and we came from there. So I have experienced that thing. That is very conveyable, and like at that time I have seen there was no plastic bags such here and there. So yeah, that was like traditional culture, but it was very like, if we are again using that thing, that would solve many of the problems.
see, another thing happens if you look at your psychology when you are going shopping, and let's say you are carrying your own bag. So maybe it's a plastic
Yes,
bag.
sir.
Okay. So you will hide it. It's an empty bag. Okay. Maybe you'll put it in your pocket. When you are bringing things, then you are so full of pride.
Yes, sir.
And then you are carrying this plastic bag through which others can see what you have bought.
Yes, sir. So that is the very right question. Actually, it came in my mind also when I grown up. Then I started using my backpack instead of using that empty baggage in my hand. I started using my college backpack. So it's like very fancy also, and I used to carry things in my backpack.
So that is one direction that, as we mentioned, technical design and emotional design. These two things are very important for any viable solution to be there. So if you do not understand the emotions of the people, okay, they will not accept your solution. But
Yes, sir.
technically also it has to be sound.
Yes, sir.
Um,
Because
huh.
most of many solutions are there in the market, like biodegradable plastics and these all things, but maybe they are expensive, or maybe they are maybe I don't know what is the reason people are not accepting those things, and continuously things are coming in wrapped in the plastic. Even I was thinking about that thing. We used to buy the pack of kurkure and this packaged food. So either they came in the plastic or in the tin boxes, right? So when it came in tin boxes, it become pricey.
Hmm.
Yes, sir. So in between the tin boxes and in between the tin boxes and plastic, we need something, but still like it's very it's it's again I am just thinking, but I have no solution for that. Actually, it's very disturbing for me.
I think it's important to think solutions would be there.
Yes, sir.
Solutions will come about. We need solutions which are easily reusable, easily biodegradable. Okay, we do not want to exert too much pressure on this biodegradability environment also, because after all this biodegradation will happen by some biological element only now.
Yes, sir.
So if you have too much of this biodegradable item, and then again it will create a problem.
Sometimes I thought that it's the seller's responsibility who is selling the products in the wrapped plastic. So maybe he can also take some initiate that like some like buy back something. If we are returning the plastic, we'll again compensate for that.
Good
Something.
idea, very good idea. And many places I find in Europe that you return the glass bottles or the plastic bottles, and it gives you a dime, gives you some coin in return. Okay, so Jaydeep, thank you very much, and let's move over to somebody else. Jaydeep, you are in which department? IIT Guwahati.
Sir, I am in the bioscience and bioengineering.
Acha, you are in bioscience and bioengineering. So all this
Yes, sir.
is very important to you. You can contribute a lot in this area.
Yes, sir. Yes, sir. First, I actually Galeria melonella is a moth. So I was also studying about it. That is the only moth that can eat the plastic. That I haven't deciphered yet now, right now, because it takes lots of time. So one moth is also there which can eat the plastic. So I have one plan to go for that.
It's a good idea, but then what happens is definitely you should pursue this approach, but then this problem may arise in the future that there'll be lots of these pots.
Yes, sir. Exactly, exactly. Lots of moths will be there. Yeah.
So because they are providing a lot of plastic.
Yes,
So
sir.
we have to minimize plastic also, but inevitably there'll be some. So 100% containment will not be there. And then the moth can play a role.
Yes. Okay, sir. Thank you, sir.
Thank you. Thank you. Let's move over to somebody else.
Dear participant, is there any query?
You should just, one thing that we do these days in class, we ask, let's say, Jaideep can nominate somebody.
Yeah.
So then the chain is maintained, everybody is alert. So you take somebody's name and he asks a question or makes a comment.
Dr. Balaji Nayak.
Dr. Bala. And after that, Dr. Bala will nominate somebody.
Dear participant, is there any question? Mr. Rahul Malhotra. I think.
So I found it
Yes,
very
yes.
interesting,
Yes, sir.
very useful, this concept of nominating. And this is what is prevailing in social media. So you do something and then you nominate somebody, and then they do something, do that thing, and then they put their pictures that they have done it, and they nominate. And the cycle goes on.
Okay.
Sir, I would like to ask you something.
Sure.
So about the sustainability aspects that you were talking about, the various laws that we need to keep in mind. But don't you think with the role of technology improving day by day with the first, second, third, and fourth revolution industry, how much do you think sustainability will be an aspect for us, especially for a developing country like India? How much do you think? Because we are already behind in the industrial revolution, and in order to match that, don't you think a country like India would not keep sustainability as a important factor or consider it as much?
Well, my thinking is this, that if we focus on sustainability, we will be able to achieve much more in each of these revolutions that you are talking of. So whether it is 3.0 or 4.0 and so on and so forth. Because we have a lot of human manpower. Okay? So if we make things which have a longer life, by making it shorter, we will not push these revolutions. If we think that by making it shorter, we push the revolutions, no, it is not correct. We can push this revolution by making more people participate. And if you look at the IT revolution in India, this IT revolution has not happened because of IITs and engineering colleges and things like that. It happened through books on information technology and computer sciences, which were printed at very low cost and were available in plenty. And it also happened because of lot of online courses and online information that was readily available, freely available. And if you look at the success of Google and Facebook and WhatsApp and Twitter and YouTube, they have created a very sustainable platform which can be shared freely by everybody. So you see, the values which are driving today's innovation is very, very different from the values that drove the past revolutions. IPR has become less important. Open source has become more important.
Yes, sir. Yes.
A lot of growth is happening through open source. And if we have to move, if India has to actually progress, one very good way of doing that is going the sustainable route. What our government should announce is that any company that makes products which carries a 20-year warranty will get this much subsidy or this much reduction in GST. And that would change the complexion totally. You see, the businessman is only governed by financial incentives. The scientist or the engineer is driven by intellectual incentives. The businessman has no intellectual incentives to work on. So we have to redirect our, and India always had that culture of sustainability. Somewhere down the line, we lost it and we are not encouraging it. If we encourage it, and if we say every company should design products which have a longer life, which uses less of energy, okay, less of data, more efficient, then what we find is that more products are available for larger number of people. Like, for example, you have your mobile phone. How many mobile phone, Thomas, you would have in your home or in your cupboards? Maybe half a dozen. Any suggestion?
No, thank you, sir. It seems 20 years seems a long time for a warranty for a company to give for a product. But yes, sir, I understand the point of having longer product lives.
I'm glad, but then now let us take a look. Is 20 years a long time? And why is it a long time?
Sir, because if a company starts offering some simple devices that have, suppose, a few years of warranty, and if they push it to 20, doesn't that affect their cost production model?
Now you have to devise. Now you have to devise new strategies for maintenance. Okay, and the world is moving
after sales.
After sales support. Okay. So the company need not let itself be bogged down. It sources the support to others. Okay. The design of vulnerable components can be put online in the open source. The design of the component is in open source. Maybe it can be 3D printed. And the component can be replaced. Yes, so we have to evolve new strategies, keeping in mind the new technology that is happening. So when we are talking of sustainable design, it will actually lead to the emergence of another revolution. So it does not in any way means that we will go back in time. No, robots will be there, robotics will be there, okay? But how we can multiply them, how we can support them, how can we make them more versatile, multifunctional, inevitable. So it is just, we have to rethink. Otherwise, we keep thinking from that past thing and say, oh, if we have to go forward, then it is necessary that we follow the route that the world is taking. Well, let me tell you, the world is moving very fast towards sustainability. And India, the whole of, let us say, East Asia, Southeast Asia, because of their old culture, were very sustainable in their approach. They all the time believed in recycling, repurposing, reusing. This was part of our life in the culture. If today India is very good at jugaad, it is because of this thing which is ingrained in them. Now, jugaad with the uneducated, but jugaad when it comes to the educated, then it is not jugaad. Because if you are not haphazard, okay, अभी तो हम जुगाड़ के मतलब ये भी करते हैं कि haphazard है, क्वालिटी में खराब है, solution आ गया है, there is a solution all right, but quality is not good. It is replaced by non-genuine parts. So it may be functional, but not long life. There'll be problems. But once you become creative, when the educated become creative, then they become innovative. And that is why, again, I feel that it's very important that we take some of these traditional values, and the government and educational institutes must embrace the sustainability concept. Okay. And as I mentioned, nature has thrived. Nature has thrived. 3 billion years it has thrived. So much so that even there is a justification for God because of this variety of living creatures that we have. We say it can't be other than God who has made it. It has to be all-powerful God who has made it. So, any reactions you have, Thomas?
No, sir, nothing. Other participants, if you have any questions, please ask.
Please nominate. People don't venture out.
Hello, sir.
बैठे रहते हैं. Dr. Balaji.
Hello, sir.
Yes.
So there is a one part of your talk I was listening to. You were talking about the for business houses, the financial quotient is very important, and not the intelligent quotient. And you talked about that engineers and scientists need intelligent quotient. I have little things, small doubts about that. Like business houses like Tata's and Infosys and such companies are having their business houses. They're also business houses, but they invest a lot in R&D and intelligent quotient, isn't it?
Yeah.
So, is the comment applicable to those big business houses also?
Yes, it is applicable. Acha, come again. We just repeat the question. Why you feel that? What is the comment I made, and why you feel that it is not applicable? There was an echo. I couldn't hear you properly, Jyoti. So just repeat.
Sir, you told me the business houses mainly require financial incentives. And,
हाँ,
and engineers and scientists mainly require intelligent
हाँ, intellectual.
intellectual. That's what an intelligent quotient I mean to say.
हाँ.
What I mean, in case of business houses like Tata's and Infosys, they are investing a lot in intelligent quotient like R&D and other.
Yes, very true. And there's a very good book. There was this, I think it's University of Yale or somebody. The name of the book is Companies Built to Last. If you Google, you'll be able to find it.
Yes, sir.
Companies Built to Last.
Yes, sir.
Okay. And there are many companies which have been there for the last 100 years. And they have maintained their position as 1, 2, and 3, top 3. So for 100 years, they have maintained this position as being top runners. And it is because they continuously invested in R&D. They invested in change. They were observant about change. They were observant about where the society is going, where the world is evolving, what they can do. And they would invest in the R&D. Many of these companies, they invest as much as 18 to 20% of the profits in R&D. So only these companies, they become like engineers who are driven by intellectual curiosity. It's not that salary doesn't matter, but salary is paid to us as an employer, as an employee, if we can use our intellectual capability. So companies are moving in that direction. What is a company? Company consists of us. Company consists of the values and the mission it gives itself. And companies who are able to move in that direction will always survive. And they will flourish.
Sir, a good example is Tata's, you can say. For example, Tata's were not doing good in car market for a long time.
Yes.
But recently, they have re-innovated the whole system.
Yes.
And our latest cars coming out by Tata's are one of the best in the market now.
Yes, yes. Now they are able to compete with the international players.
And they're doing it very good.
Yeah.
And as far as crash testing and such features are concerned, it is best for Tata.
See, this is where the Tata value system, which is a very much an Indian value system, is influencing the design. So Tata's began with trucks. So mostly they used to make truck chases. Those truck chases were used for buses also. And then that is why you had to climb a long height. Many steps were there before you got into the bus. And then they moved into automobiles. And Indica was one of them. That was their first venture. And when Ratan Tata, once there was a conversation, and he said that he decided to go to Italy for the design of their first automobile, just to understand the process, how they design it. What is it that they think about? So it is an intellectual curiosity that drove them in that direction. And then later they bought this Jaguar and the other company. So they bought these companies.
Land Rover.
In the process, they were able to get a lot of technology, understanding how things are done. And their first MD for production plant was a European. So they wanted to be sure that yes, we get our things right. We don't do things the old way.
In the latest, also chairman was also a German, I think. He was also an European.
Yes, yes.
Chairman. So
I
and
don't remember his name.
I also don't remember his name. They modified that. Another thing good of Tatas is that they make from salts to sweat cars, everything available in a wide range, from very low level product to very high level product.
Yes, yes,
That's
yes.
fantastic.
This is what is Indian about them. They bother, and that's how Nano came into existence. Okay, because they wanted to. Unfortunately, they did not market it properly, and it just lost out. But even today, I see some nanos moving around. So anybody who bought that nano, when was it? It's almost now 20 years. Then when did the first nano come?
Around 2000.
Around 2000. Yes, so it's about 18 years, 20 years.
Yeah.
And still you see them on the road. So it was a good product.
But I think they failed in nano. They didn't do well. They are telling that cheapest car, that mantra
It was
was
bad,
not good.
bad
That failed.
marketing. It was bad marketing. Okay. And this is where they lost out. I still feel that it has a lot of potential. If something does not take off 20 years back, it does not mean that it won't take off now. And it is a platform which can be very easily adapted for electric vehicles because it is lightweight.
Yes.
So it's a thing that we have to always explore. There are many patents. They were filed too much ahead of their time. They keep lying there. Even the patent life expires. But then the time comes now, and then people can manufacture it and they succeed. So what you can't do yesterday doesn't mean that it can't be done today or can't be done tomorrow.
Yes.
Good, Joydeep. Let's have one more and then I'll finish. I have another round of questions. Joydeep, you just nominate at random without any malice. Just that's the only way to set the ball rolling. Otherwise, everybody keeps thinking. I know they all have questions. It just cannot be that they don't have questions.
Yeah.
Participants, please, if you have any questions.
Deepak Kumar, Amit Jha. अपना भी ज्ञान दे दो ना मुझे थोड़ा सा उससे मेरी थिंकिंग रिफाइन होती रहती है When you give me feedback ना वो फीडबैक फॉर्म होता है ना तो वो फीडबैक फॉर्म तो ऑर्गेनाइजर्स के लिए जो स्पीकर है उसके लिए फीडबैक फॉर्म जो है वो क्वेश्चंस हैं
Sir, it seems like everybody has had a very heavy
Okay, very fine. So let's move. कोई पूछ रहा है?
नहीं sir, it was just me.
बाद में पूछ लेना कोई बात नहीं. We'll give you another 5
so
minutes.
just a few. Let's see.
Can you see the screen?
Yes, sir.
Good. Now, when I was looking at this plastic waste, I took the analogy from planets. Okay. So a planet is a celestial body that is in orbit around the sun. Has sufficient mass for its self-gravity to overcome the rigid body forces so that it assumes a hydrostatic equilibrium, becomes nearly round, and has cleared the neighborhood around its orbit. Now, these are the three things that have to be satisfied before any celestial body is called a planet. So when there was this debate of whether Pluto is a planet or not, it was these three criteria around which they were trying to assess. The third one was important for me because it said the planet has cleared the neighborhood around its orbit. So what is it that it is doing that it is able to clean its environment? Now you see, you have this Kuiper belt. There's another belt where there are a lot of these small objects. They are floating around, going around. Neptune is chucking them inwards. Jupiter is chucking them inside. Okay. But continuously, the path of these, the moon, if you look at moon, it is not able to clear its path. And that is why it has so many craters in it. Earth is able to clear its path, so it does not have so many craters. Okay. Now, exactly the same thing is happening. We are producing plastic waste. Once the plastic waste goes outside our reach, then it is impossible to clean it or clear it. As long as it is within our reach. So gravity was the reach. Through the gravity, and the Earth is able to reach, or other planets are able to reach, and they are able to clear their path. Okay? Either they are able to toss it somewhere else, okay, or they will absorb it. Mostly they just toss it away. So that is why you have these two belts. So these belts are areas where you have the waste. The rest is all your nice living. So let us say this is the cosmic dump waste, dump yard. Now, our basic approach is to relook at the product consumption recovery chain. Like my friend was saying, I think Joydeep was saying, or Thomas was mentioning. That we have this product which is made by the factory. It is consumed by the people. Okay? And then something which is left over has to be recovered. We have to look at this chain. What is the root cause of the waste? How can we create a circular economy in the system? So a circular economy that the things are fed back into the economy. The waste goes back to the factory. So what are the clues that we can have from nature, etc.? Now, the major problem is that products are manufactured in the industrial area and are transported to retail outlets in the form of small packets, bottles, sachets, and containers. So if you look at the food which is cooked in your kitchen, okay, so it is cooked in the kitchen and then you eat it on your dining table. You don't require any packing material. Do you? Of course not. Okay. The packing material is required because the point of manufacture and the point of consumption is far removed. Then the other problem is that the time of manufacture and the time of consumption is also far removed. So there is the issue of space and there is the issue of time. Because of this, there is this issue of shelf life. And so you require packaging material. a thing has to be transported, because it has to be transported a long distance. There are shocks, vibrations. You have to properly package it, because will take some time to reach the shop. The material may deteriorate. It's a biological food. It's a food item. So it may deteriorate in quality. Some fermentation may happen, some bacteria may. And so you require packaging. So now the issue is that how do you take care of these problems? One, of course, is that you bring this location of production closer to the location of consumption. In some cases, it can be done. You go to the market and you eat momos, hot steaming momos. There is no packaging to be done. You cook in your kitchen. Pepsi came up with this fountain Pepsi. So the water was locally sourced, and then there was a concentrate in the form of a powder, and the concentrate was put in the water. The water is chilled and he serves you in a glass. It became more sustainable. It was a paper glass, but still there are problems. I go to Europe and I see lots of people, they carry their own bottles, metal bottles, plastic bottles, the good quality bottles, which they carry with them, and they fill it with water and they drink from that. Then another problem is that the smaller the packaging is, the lesser the incentive there is to pick it up. So if you go around your locality and you look at the plastic waste, it is the polythene bags which cost very little, or it may be tomato ketchup sachet, or tobacco, or pan masala, parag, pan parag, unke jo packets hote hain. Now, it is not convenient to pick them up. If it is of some value, then it would be picked up. So this is the problem which is at the root of the pollution that we see. You look at bottles where I showed you the picture of these birds dying in the Pacific, on a Pacific island, because of they were eating plastic parts. What were these plastic parts? They were essentially lids of bottles. Now there is a challenge that how I can make the bottle and the lid as one piece. If we can do this, then a major problem will be solved. So there is scope for innovation. If you can come up with a good solution that you can tighten the bottle, and at the same time the lid never becomes separated from the bottle, you have a winning sustainable design, which will take the industrial development forward. You look at a aluminum Coke can. Okay, so in the Coke can, you open the can, and the part that is used for opening the can is always attached to it. If it is not attached, it will create a problem. It will go into that environment. So you have these Johnson earbuds. So a small piece of plastic on the two ends, you have some cotton, and then they get thrown away. And then they can get into the nostril of birds and then animals. And lots of problems happen. So how it can be, how can the waste be put back into the system? That is the challenge. So recommend the use of bioconsumables material below a particular size. So when we say tomato ketchup or pan parak pouch, then here we must use biodegradable. Let's not use biodegradable material for larger items. If you use it for larger items, then you will create more moths in the in your environment. The second is do not allow non-bioconsumable to leave the no-hold zone. So there is a zone. Once it escapes that, then you are not able to bring it back. Once it enters into the water body, then you can't bring it back. Then it reaches the ocean. Then it goes into the far away Pacific island. When this inexpensive, low-cost polythene bag goes out of your house and wind takes it away, then nobody wants to pick it up. It has no value. So there is a no-hold zone that you must define and say, okay, my plastic should not go beyond this. That is what we meant by the Cooper belt. And so you have factories here, you have shops here, then you have houses, then you have the environmental nature around it. Okay, this is where manufacturing is happening at the factories. From factories, it is going to shops. From shops, it is going to houses. Now, there is good interaction between the factories and the shops. Every shop is catering to maybe 500 customers, 100 customers, whatever it is. Okay. But once it reaches the house, then it becomes very difficult for the factory to pick it up. So good relationship and interaction between the factory and the shop. And plastic, which is of low cost or it is of no value to the household. The purpose of that packaging was merely to ensure the life of the product. Okay, that should not go to the house. So how can we do that? Yes, that is the challenge before us. So we said, this is the zone. This is the hold zone. Factories and shops. That's the hold zone. Beyond that is the no hold. Now you can't hold it. Okay, so then we were looking at examples from nature. And then if you look at an orange, so what are you interested in? You're not interested in the peels. Okay. What you are interested in is in the juice. Now the juice is contained in how many packaging? So there is one small ampule which contains the juice. And then these ampules are packed into one slice of the orange. And then many of these slices that you have there, 5 slices that you have there, are packaged inside another one. So there are layers of it, layers of it. And this is how nature is managing. And each one of these layers have a different function. Some are very fragile, others are more rugged. Okay. Again, you have this example of coconut. So you again here you see there are 3 layers. The first layer is taking care of shock absorption also when it falls from the top of the tree. Okay. And then you see how it is packaged within packaged. Now, similarly, we can think in terms of packaging. of our material. So when I go to the shop, the item is there in a zip pouch. Inside the zip pouch is, let us say, a paper bag. So when I go to the shop, he does not give me the plastic package. What he gives me, he opens it and he gives me a paper package. Now I have to bring that paper packet from the shop to my home. It's not a long distance. After it comes home, then it is put in my own container, maybe an airtight container, or it goes into the refrigerator, whatever it is. So at the shop, we ensure that the plastic waste does not reach the home. So here I am giving you examples of many layers of packaging, 4 layers of packaging. Okay? And you have the manufacturing unit, you could have one level of packaging, level 1, which is a container, which has many small pieces in it. Okay? Then you may have a carton inside it. So you have many cartons inside level 1 packaging. Then the cartons would have smaller packets in it. And then the smaller packets can be opened and you have a paper pouch inside it. Now, paper pouch is what I pick up. With the material, I pick up that. The container and the plastic pouch goes back to the factory. Because now there is a continuous, there's a close link between the factory and the shopkeeper. Or maybe in between there is a distributor, could be a distributor also, but anyway, there is a close link. There is a transportation system there. So we were looking at concepts, and we said we have the container, which is a lockable panel. So when an empty container has to go back to the factory, it need not occupy a lot of space. Or it is something which is stackable. And we think in that direction, perhaps a solution could be there. We have concepts of containers and we have concepts of refrigerated containers. And then from those refrigerated containers, it comes immediately to my refrigerator. So how we can do it? So it's a matter of redefining this supply chain. We have not thought about the supply chain from the concept of sustainability, from the viewpoint of sustainability. That is where the major problem is. Nobody is thinking about it. The moment we think about it, there are a lot of solutions around. We just adapt it. Everybody is happy. In fact, the factories will, business houses will benefit. Because many of these packaging can be reused. And if it can be reused, their cost comes down. Their profits will increase. So here another example of eggs, larger container, big container, and from there it comes straight to the fridge. So now the refrigerator will also be redesigned. Refrigerator will become a storage unit also. And this is what is happening. You see, many people are buying large refrigerators. It is not to take care of the day-to-day requirements which are large. They are using it like a storage unit because things last much longer. They put even their masalas and their biscuits and their snacks in the refrigerator because they remain crisp. So again, you have redesigned. So you can have polypropylene hinge design. Everything is one piece. It's not that you have a separate lid. The moment you make things separate, then they escape your old environment. There were some other zip pouches, etc. we were talking of. Then there is edible packaging. So like you have the cream roll. So the outer is what is packing the cream inside, and then you eat everything. And similarly, you could have straws through which you can drink and you can eat it also. It is like a snack. So often you have those sticks, bread sticks, which come with the soup. If only you could design the breadstick also with a hole, which is a very simple thing to do. The breadstick has a hole, so you can drink your soup also with it and eat it also. So we were looking at those zip pouches, and inside the zip pouches, you have a paper bag. Okay, so what the shopkeeper gives you is not the complete plastic thing, gives you the paper bag, a strong paper bag. Now it will reduce and it will increase the profit because these plastic bags can be reused. You have many other examples of edible, an edible glass. You could have something like this, which has cream in it, or it has tomato ketchup in it. So things like that. So thank you very much. And if there is time, we can have a few questions, but I don't think we have time. So 1:33 is already.
Yes, sir. It's past. It's 1:30. Okay, so participants, we are winding up this session.
If there is one quick question, then you can have that.
Yes, and if anybody has a quick question, please, now would be the right time.
You can put it in the comments. I would suggest to the organizers that they should evaluate the participants in these online programs by the number of questions they ask.
So we do have our mandatory quizzes, but we should also be considering.
So if they ask more questions, you can give them a certificate.
Surely, sir.
Good. Thank you very much.
Thank you so much, sir. Thank you so much for the session. All the participants are requested to please be more active in the sessions, and also the next session will be a practical one.
Yes.
So kindly be prepared for that accordingly. There will be a practical session, the next one, and at 2 p.m. So I would like to thank Lalit sir once again for his really enlightening views on the environment and sustainability. A whole new perspective has been gained over here, sir.
Thank you.
Thank
So
you.
what is the practical session on?
Sir, this is based on Altair software. Altair software, and they will showcase how the practical, how they are considering the design aspects in the software.
Which software is it?
Altair, sir, 3D model.
Altair. Okay.
Yes, sir.
So they have the sustainability module in it?
Yeah, I think they have.
They have. Even SolidWorks has it. Many of them have it.
Yes.
Solid also has it. Fusion 360 I haven't, but they must be having a module.
Yes, sir. Yes.
Okay. So thank you very much.
Thank you, sir. Thanks a lot, sir, for accepting.
And any student who has any question, please feel free to email me. Okay.
Sir, few participants have requested your presentation copy, sir.
So anyway, it must be recorded. So this recording is there. Okay.
Yes, sir.
So make use of this recording.
Yes, sir.
Okay. Thank you.
Thank you, sir. Thank you.